Breakthrough battery lets EVs charge in minutes. When purchasing an electric vehicle (EV), upfront cost and range are important considerations, but having to spend hours waiting for your EV to charge is another significant barrier. How long does it take to charge is one of the most frequent queries received from non-EV owners. What if an EV battery could be recharged in less than 10 minutes? Hello and welcome back to Incredible Tech. Today, let's talk about the breakthrough in the battery industry that would expand the EV market. Make sure to stay until the end of the video. EV batteries currently in use. Electric cars, EVs, plug-in hybrid electric vehicles, PHEVs, and hybrid electric vehicles all depend on energy storage systems like batteries, HEVs, lithium-ion batteries, nickel-metal hybrid batteries, lead-acid batteries, and ultracapacitors are the main battery types now used in EVs, PHEVs, and HEVs as energy storage systems. Due to its great energy efficiency, high power-to-weight ratio, good performance at high temperatures, and better energy ratio per weight compared to other energy storage systems, lithium-ion batteries are most frequently used in EVs. A lighter automotive battery translates into more miles per charge. The main drawbacks of LITHIUM batteries, however, include the high temperature that arises during battery operation, the high cost of production, and problems with recycling old batteries. As a result, in recent years, interest in graphene batteries as EV energy storage devices has increased. Now let's know about graphene. One flat sheet of carbon atoms is arranged into a stabilizing honeycomb lattice to form graphene's two-dimensional, 2D, graphite structure. Although there are various techniques to make graphene, the best method is called plasma-enhanced chemical vapor deposition, PE-CVD. The PE-CVD process has lower working substrate temperatures, transfer-free growth, and catalyst-free growth as its main advantages. In PE-CVD, a layer of graphene is produced on a copper of nickel plate by heating a mixture of gases, including carbon, into a plasma. Afterward, graphene is removed from the plate. Graphene's electronic characteristics. One of the reasons graphene is so appealing to molecular electronics researchers working in nanotechnology is because of its exceptional electrical conductivity. Because of the unusual way that the carbon atoms are arranged in graphene, electrons may readily go through it at very high speeds without encountering a major risk of scattering, conserving valuable energy that would otherwise be lost in other conductors. Because the electrons don't appear to slow down or localize, scientists have discovered that graphene can continue to conduct electricity even at the supposedly zero carrier concentration limit. The periodic potential of the honeycomb lattice of graphene interacts with the electrons traveling around the carbon atoms, creating new quasi-particles with rest mass, so-called massless DIRAC fermions. This means that graphene conducts electricity indefinitely. Additionally, it was discovered that they move much more quickly than electrons in other semiconductors. What benefits can graphene offer batteries? Imagine a cell phone battery that could be fully charged in just 15 minutes and last for more than a week. Unfortunately, there are two ways in which a lithium-ion battery's performance is constrained by existing technology. The first factor limiting a battery's energy capacity is the charge density or the number of lithium ions that can be crammed into the anode or cathode. A second aspect that affects a battery's charge rate or how quickly it recharges is how quickly lithium ions can move from the electrolyte to the anode. It is possible to significantly increase the energy capacity and charge rate of rechargeable batteries by turning graphene into electrodes, anodes, and cathodes. The superior electrical conductivity, excellent mechanical flexibility, good chemical stability, and large surface area of graphene are the causes. As observed by researchers, the inability of LIBs with pure graphene anodes to provide steady potential outputs creates a barrier to their practical usage. Researchers are devising several solutions to get around this issue and boost the performance of graphene electrodes. Types and technologies of graphene batteries. Based on graphene, a variety of battery technologies and types can be created. Solid-state batteries, supercapacitors, graphene-enhanced lead-acid batteries, graphene sodium-ion batteries, Graphene aluminium-ion batteries and graphene lithium-ion batteries are some of the most promising among them. Graphene batteries benefits. Graphene-based materials have a high surface area, porosity, extraordinary strength, and lightness. These materials are useful for energy storage because they are flexible, good conductors of thermal and electrical energy, and have high charging capability. Due to graphene's excellent electrical conductivity, raises electrode density and speeds up the chemical reaction inside the battery. More power can be transferred and charge speeds are increased for producing less heat. Additionally, graphene performs better than lithium while undergoing less deterioration, thus extending the life of EV batteries. In addition, compared to many other EV batteries, graphene batteries are more affordable and environmentally friendly. Implementation of graphene batteries in electric vehicles. Graphene lithium-ion batteries are anticipated to be developed within the next 1 to 3 years. Solid-state batteries over the next 4 to 8 years, and graphene supercapacitors within the next 10 years. Lithium-ion batteries may eventually be replaced with graphene sodium-ion and graphene aluminium-ion batteries because they are less expensive, easier to recycle, and more prevalent in nature than lithium. Tesla battery made of graphene. Is it possible? Graphene, dubbed the wonder material of the 21st century, has a long list of qualities. It is 200 times stronger than steel, but 6 times lighter. Conducts electricity more efficiently than copper and is nearly transparent. It is also impermeable to gases. Additionally, its properties might change when chemical elements are added to its surface. These characteristics allow graphene almost unlimited possibilities. However, the majority are currently not readily available in the market. Elon Musk, CEO of Tesla, adds his perspective. Around the time that Xinhua's report was published, Musk stated that he believed it would be possible to develop an electric vehicle with a 500-mile range. In reality, he remarked, "We could accomplish it pretty soon, but the cost would go up." He made no mention of the usage of graphene in the production of such a vehicle, though. Issues with graphene batteries. Despite its advantages as energy storage solutions for EVs, graphene-based batteries have some drawbacks. Main restriction is the lack of mass production methods for making high-quality graphene batteries. A kilogram of graphene now costs between tens and thousands of dollars to produce, which is far more expensive than the $15 per kilogram production cost of activated carbon. Possibilities of graphene batteries for EVs. Although it is already conceivable to employ graphene batteries in EVs, they are not yet commercially available since the additional study is needed to create mass production procedures and better understand the material's practical capabilities. Many businesses have expressed interest in using graphene batteries to power EVs. For example, Spain-based Graphenano has partnered with a China-based player to develop a graphene polymer-based battery that can give EVs a maximum range of 500 kilometers and a recharge time of under 5 minutes. That's all for today. Share your opinion about this incredible innovation in the comment section below.